So, what features does SparkR have? We've already talked about the scalability with many machines and many cores. Operations being executed on SparkR data frames get automatically distributed across all the cores in the cluster. As a result of all this, SparkR data frames can be used on terabytes of data and run on clusters of thousands of machines. Another benefit is the data frame optimizations. SparkR data frames inherit all the optimizations made to the computation engine in terms of code generation and memory management. Then there are all the data sources APIs. By tying into Spark's SQL data sources API, SparkR can read in from a variety of sources, including Hive tables, JSON files, SparkR files, etc. Then we have the RDDs as distributed lists. SparkR exposes the RDD API of Spark as a distributed list in R. For example, we can read an input file from HDFS and process every line using lapply on an RDD. In addition to lapply, SparkR also allows closures to be applied on every partition using lapply with partition. Other supported RDD functions include operations like reduce, reduce by key, group by key, and collect. Then there's the serializing of closures. SparkR automatically serializes the necessary variables to execute a function on the cluster. For example, if you use some global variables in a function passed to lapply, SparkR will automatically capture these variables and copy them to the cluster. In addition, we can use existing R packages. SparkR also allows easy use of existing R packages inside closures. The include package command can be used to indicate packages that should be loaded before every closure is executed on the cluster. Now we're going to look at how we interface with SparkR. There are several ways to interface with SparkR. You can interface through the Spark shell. You can interface through the SparkR shell. The difference between the two being that the SparkR shell has the SQL context and Spark context already created for you. You can use RStudio, which is an integrated development environment. You can use notebooks. Notebook gives you a interactive web-based editor, which you can do all sorts of interesting things with. And there's the Data Scientist Workbench, which provides a unified platform of diverse tools. It's capable of using open source tools, including Jupyter and Zeppelin, as well as RStudio. And we're going to look further into these. The entry point to SparkR from the R environment is the Spark context. This connects your R program to a Spark cluster. The first step in any Spark application is to create a Spark context. Spark context allows your Spark application to access the cluster through a resource manager such as Yarn or Spark's own cluster manager. It represents the client connection to a Spark execution environment and has to be created before using any of Spark's features or services in your applications, such as RDDs, accumulators, broadcast variables, etc. To work with data frames, we also need an SQL context, and this is created from the Spark context and provides the interface into Spark SQL. If you're working from the SparkR shell rather than the Spark shell, the SQL context and Spark context will already have been created for you, whereas in the Spark shell you'll have to create those yourself. With an SQL context, applications can create data frames from a local R data frame, from a Hive table, or from other data sources. SparkSQL is a Spark module for structured data processing. It is a distributed SQL engine designed to leverage the power of Spark's computation model, which is based on RDDs. Unlike the basic Spark RDD API, the interfaces provided by SparkSQL provide Spark with more information about the structure of both the data and the computation being performed. Internally, Spark uses this extra information to perform extra optimizations. SparkR works with data frames, which means we will need an SQL context, which can be created from the Spark context. The entry point into all the relational functionality in Spark is through the SQL context. There are several ways to interact with Spark SQL, including SQL itself, the Data Frames API, and the Datasets API. Data analysts will likely use SQL as their query language. The SQL function on a SQL context enables applications to run SQL queries programmatically and return the results as a data frame. Spark SQL also includes a data source API that can read data from other databases using JDBC. This functionality should be preferred over using JDBC RDD API. This is because the results are returned as a data frame and they can be easily processed in Spark SQL or joined with other data sources. The JDBC data source is also easier to use from Java or Python, as it does not require the user to provide a class tag. Datasets are similar to RDDs. However, instead of using Java serialization or CRY-O, they use a specialized encoder to serialize the objects for processing or transmitting over the network. When computing a result, the same execution engine is used independent of which API or language you are using to express the computation. This unification means that developers can easily switch back and forth between the various APIs based upon which one provides the most natural way to express a given transformation.